Okay, PreCalc 4.4, graphs of sine and cosine sinusoids. I will be able to, after this section, review the basics of unit circle, understand the graphs of y equals sine x and y equals cosine x, graph sinusoids and their transformations. Now we'll be able to talk about A, B, H, and K, where A is the vertical stretch and compression, B is the horizontal stretch and compression, H is your shift of the graph left or right, and K is your shift of the graph up and down. That's the same with cosine, and we'll be exploring that through this section. The amplitude is the absolute value of our A value. If A is negative, it is a reflection across the x-axis. We'll have a period length, a general period of sine and cosine is 2 pi, and that period is adjusted based on our value for B. Our phase shift, which is H, and our vertical shift, which is K. And we'll also be modeling periodic behavior with sinusoids. Now, the graphs of sine and cosine you should be very familiar with. We've had our unit circle. And the graph and sine and cosines are two of the parent functions we learned about in chapter 1. In section 3, for the basic sine and cosine functions, the period is one full circle. The period for sine and cosine is 2 pi. We're just going to get rid of this stuff. I wrote it another time. To graph a sine or cosine curve, this is what we're doing today. Okay, so we're going to work with sine, and to help us, I've got a mnemonic device for sine. We got axis, high axis, low axis, and it's Sahala, S-A-H-A-L-A. And the reason why we're going to do it this way, I'm going to explain as we talk about the points that we need to graph. First, you're going to divide the period into 4 equal increments. So our period is 2 pi, so we're going to divide it by 4, which is pi over 2 increments. Okay, we're going to mark these increments on our x-axis. We're going to determine our starting point. For sine, that starts at 0, 0, and cosine will start at 0, 1. Okay, because it starts on the high side of the axis. Cosine and sine starts on the low side, or at the axis. We're going to plot the 5 key points, x-intercepts, max, and min. Now these 5 key points are determined by our division here. And we have divided 2 pi into 4 equal parts that are pi over 2 apart, and that one starts at 0. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. I hope you recognize these as our x and y axis, our quadrantal angles. 0, pi over 2, pi, 3 pi over 2, and then again at 2 pi, where we started at 0. We're going to convert this into a smooth graph, a smooth curve, and we've got to remember the values we have at sine. When we have our degree at 0, or our radians was 0, our sine was 0. When our radians were pi over 2, our sine was 1. Our radians is pi, sine again was 0. When we went down to 3 pi over 2, our sine was negative 1. And then we went back up to 2 pi, our sine is 0 again. So our graph looks like this for one full revolution. And that, remember, the graph was determined by our sine values of our quadrantal angles, because we split our 2 pi period into 4 equal parts, and this is 1, 2, 3, 4, but we have 5 important points 5 key points that we need to graph on the either side of those 4 equal parts. 0, pi over 2, pi, 3 pi over 2, and 2 pi. I did errantly click on my graph. Remember, it continues on forever from negative infinity to infinity along our domain. That's what our domain is. Our range is from -1 to 1. It's the lowest it goes is -1, the highest it goes is 1. It's continuous all the way along that domain. It's alternately increasing and decreasing in periodic waves. So if I went back here, I'd notice that it's increasing to pi over 2, and from pi over 2 is going to decrease to 3 pi over 2, and it continues the increase and decrease throughout the entire wave. Now it's got an absolute max of 1, an absolute mid of -1. Its symmetry is odd, which means it's got point symmetry right here from the origin, a 180-degree rotation. If I was going to rotate this part of the wave, the sine curve, the sinusoid, 180 degrees, it would come back here. Okay, it's bounded above and below. There's no horizontal asymptotes, there's no vertical asymptotes, and its end behavior. Now this is an important point. In its end behavior, the limit of sine of x as x approaches -infinity and the limit of sine of x as x approaches infinity do not exist. The function values continually oscillate between -1 and 1 and approach no limit. Okay, and that's the sine curve that we have. Now, please keep in mind, sine and cosine will be graphed in a similar fashion, but I want you to pay attention to Sahala, this mnemonic device for sine. So for sine, Sahala, you start at the axis, you go high, you go back to the axis, you go low, and then back to the axis, and that's one full cycle. The reason I have it like that is because as we go through here, we're going to learn about the changing of our period. And during that changing of our period, when we divide it into 4 equal increments, we're going to learn that although the period has been stretched or shortened based on our value of b, our b value in our function, we're going to realize that they always start at the axis. They'll go high, and whatever that is, determined by our a, amplitude, then back to the axis, and low, and back to the axis again. So keep that in mind. It's going to be the same pattern. It's going to be helpful for us to not only graph sine, but remember, graph the sine's inverse, cosecant. Okay. Now let's go on and check out our cosine graph. Here to graph the sine or cosine curve again, but we're working specifically with cosine. Again, I have a mnemonic device for cosine. It's Chala. It's C for cosine, and then H high, A for axis, L for low, A for axis again, and H is high. So that's Chala. Okay, and you can talk about Sahala and Chala as, you know, two really cool sisters, or however you want to remember sine and cosine graph shorts. But again, we're going to mark these increments of you know, dividing our 2 pi period up into 4 equal parts that are pi over 2 apart. Okay, and again, it's going to be 0 and pi over 2, pi, 3 pi over 2, and 2 pi. Again, there are quadrantal values. Sine again started at 0, 0, and I should probably have parentheses around that. Freehand these with the computer. And cosine starts at 0, 1. And again, I'm going to put parentheses around that so you can see these things again. These are our coordinates. Okay, for where sine and cosine initiate or start in the general form. Plot the 5 key points. Again, x-intercepts, max and mins. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remember, we divided the period into 4 equal increments. Those increments are pi over 2 apart. We start at 0, we add pi over 2. We add pi over 2 again, we get to pi. We add pi over 2 again, we get 3 pi over 2. We add pi over 2 again, we get 2 pi. That is where these critical key points come across for cosine. They also are the same way we came across for sine. Then we're able to put the graph across because cosine high in this form is 1. It goes down to the axis as pi over 2. It goes to -1 at pi, goes to the axis at 3 pi over 2, and it goes to positive 1 at 2 pi. So that is one period um, from crest to crest for our cosine. And we could continue it on, going back so you could see more of this, but it generally does this the whole time, just like sine did, except it's shifted off a little differently. But our domain for our cosine is pi, negative infinity to infinity. Our range is -1 to 1. Again, it's oscillating between -1 and 1. It's continuous, alternating, increasing and decreasing in periodic waves. Hey, this is a lot like sine. Matter of fact, because they're sinusoids, they're the same patterns that they have. They have an absolute max of 1, an absolute min of -1. Symmetry is even. It's bounded above and below. There's no horizontal asymptote, and there's no VA. And again, the end behavior, the limit of cosine of x approaches, when x approaches negative infinity, and limit of cosine x as x approaches infinity, they just don't exist. The function values continually oscillate between -1 and 1 and approach no limit. Okay, now this is another graph just like the one we did with sine earlier. We connected points for a smooth curve. And so this is really more of you guys learning about connecting points and connecting why I know, or why we know, what the sine and cosine curves look like, and where we start, where we stop, and what's a cycle, how we're able to find those 5 key points. And again, going back to Chala, cosines, you start the high, start here at 1, go to the axis, 0, go low at -1, go back to the axis at 0, and back to high at +1 to graph your cosine. Now let's look at what A does. A is in the position for amplitude, the absolute value. Okay, that's the amplitude. This result is a vertical stretch, compression, or reflection over the x-axis. Now it's a reflection over the x-axis when it's negative, but this absolute value is called the amplitude. So keep that in mind. If A is negative, that is not included in the amplitude. The value of A, the absolute value, is considered its amplitude, and that's the distance it is away from its axis. Now, to find the amplitude of each function and use the language of transformations to describe how the parent function is transformed to the given graph, then graph all 3 functions. Well, let's describe it. Right now in this general graph, A is 1, so the absolute value of A is 1. B happens to be 1 as well. And now my period, and we're going to talk about that. The period of the graph is 2 pi, but it's 2 pi over your B value. So keep that in mind. In the future, we're going to be using that. I'm just getting you eased in that it's going to be 2 pi over the absolute value of B. And so we're going to get this first one graphed. Now, first thing we're going to do is find the key points. Okay, then there's 5 of them. We're going to take 2 pi and divide it by 4. In this case, I got to take the 2 pi divided by 4. And again, I have pi over 2. And I'm going to extend the graph over 2 full periods. So we go 2 pi, -2 pi, we add pi over 2, -3 pi over 2, add pi over 2 again, we get negative pi. And I'm just increasing by pi over 2. So I've already put my points in here so you can see what's going to go on here. But again, this first graph, it was sine, okay? And when we start it, we're looking at the idea is generally I start graphing sine on the axis, okay, and on the axis for sine, it's Sahala. Remember, sine, axis, high, axis, low, axis. So for graphing sine, I start at the axis, and I go to my first critical point, and I go high, okay, that's the blue, so we're graphing our blue, and I go low, back to axis on the way to going low, and back to axis. Now if I keep looking at that, and it continues itself forward and backward, okay, so sine starts at the axis, goes high, back to the axis, goes low, back to the axis. But I can reverse this going back here. I can say, hey, it started here, at the axis, high, axis, low, axis. So it gives me an idea what's going on with it as I cycle through. And it's all about me identifying the fact that these 5 key points. You know, I'm dividing 2 pi by 4 that are separated by pi over 2 are really going to help me. And remember, I start at 0, pi over 2 pi, 3 pi over 2, 2 pi. And I'll always start at 0 and add them up that way. And then I'll just keep going on the same period and cycle backwards to include a second cycle of my sine function. Now we're going to do this again, and again this time I'm looking at it, the greens here, and I got 3 sine of x. Now 3 is my a, my amplitude. It's positive, so I'm not going to flip my graph, but the absolute value of a is 3. That's my amplitude. The absolute value of b happens to be 1. That's the number right here next to x. And again, my period is 2 pi over 1. And again, keeping in mind my length of my period is 2 pi. So I'm going to take 2 pi, the period length, divide it by 4 and find my 5 key points. Well, they happen to be the same 5 key points that we found already. Negative 2 pi, negative 3 pi over 2, pi, negative pi over 2, 0, and then repeat my original 5 key points, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, by dividing again my period by 4 and finding that their separations by 2 pi, and I start at 0 and work my way up. Now, in this graph, as I'm going through, if I can get this set up so you can see my graph and where I'm going, I have an amplitude of 3. So here, if I start at the axis, I'm going to start normal at the axis, but in this next one, I'm going to take normally at pi over 2, I would be at 1. But what's 1 times 3? It's 3 high. And then I'm go back to the axis. Okay, but now I'm going to go to my 3 pi over 2, and it's 3 lower because it's negative 1 times 3. So I'm going to graph this here as I go, and it wasn't pretty, but it's you're getting the idea that the green here is my 3 sine x graph. I hope your graph drawing's better than mine, but remember, it's amplitude stretches the graph 3 units high, and generally that sine of 3 pi over negative 3 pi over 2 is going to be 1, but 3 times 1 is 3, and my sine x of pi is 0, and 3 times that is 0. My sine of negative pi over 2 is going to be a 1. It's a negative 1, and my 3 times that is negative 3. And that's what I'm doing. That's how I'm getting my graph here in green. Now, this next one here, again, we already have our 5 key points. We found our 5 key points by taking our period, 2 pi, dividing it by 4, and coming with a pi over 2 separation. We came up with our 5 key points, 0, pi over 2, pi, 3 pi over 2, and 2 pi, and we got that graphed. We're graphing sine, so we always start at the axis, and then we will go to high, and then we go back to the axis, low, and we go back to the axis. But keep in mind, if my a value is negative, that is a reflection of my graph across the x-axis. So now, although my amplitude is still 2, okay, so my a is 2, this causes a flip, okay, of my graph. So I reflect it in the x-axis. I have a b of 1 still. Okay, b is 1, and my period is 2 pi, and in the future I'm going to take my b value and divide it into 2 pi and be able to either shorten or lengthen my period based on that. And I'll divide that period length into 4 equal parts, and I'll be able to graph my curve. Now, because I'm flipping it, I'll be starting at the axis, but I'll be going low, and then to the axis, and then go high because I will be flipping this. So on this one, I'll start at the axis and I'm going low because remember, it's a reflection, and it's 2, so it's 2 units away from the axis because originally it's 1, 1 times 2 is 2, and now let's go back to the axis and then 2 units away again. So this is what my graph will look like. It is a reflection across the x-axis because of the negative, and it's with an amplitude of 2 as I go through. And again, I'm just using the idea of Sahala to help me with my graphing of the sine curve. So I'll start always at the axis, but here, because I'm reflecting across the x-axis, I go low right away, and then I go back to the axis, and then I go high, and then I go the axis. So I can use Sahala to help me get this right with that negative reflection across the axis. Now, for the same reason, for the same stuff, we're going to do cosine. So let's look at the cosine graphs. We're going to find the amplitude of each function, y2 and y3, and use the language of transformation to describe how the parent function, y1, is transformed to the given graph. Okay, then graph all three functions. Well, keep in mind, I'm still going to be looking at this. My original graph, this is my parent function, y a equals 1. My b is 1, and my period is 2 pi divided by 1, which is 2 pi. Now, if I graph just that one, just so we have the idea, I'm going to do the 5 key points. I'm going to divide my period into 4 equal parts. Well, 2 pi divided by 4 is pi over 2. We've already done this. And I have my points that I'm going to graph. My 5 key points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. I started here, I numbered them out, and I numbered back. Now, keep in mind we're starting with cosine. Cosine, Chahala, excuse me, Chala, starts high because it's 1, and it goes to axis, then down low, and then back to axis, high. So my cosine cycles through just like this. So that's my parent function for cosine. Okay? Now, keeping in mind as I do this, in this next one, I'm going to have an amplitude or a vertical compression of 1/2. So it's going to be half the size of the graph that we started with. And again, A is an absolute value as I go through. Okay, and B is also an absolute value, but keep in mind right now they are both positive. And we're looking at P, and perhaps what I should do is stay consistent with showing that the absolute value of A and the absolute value of B, I've got the absolute value of A is 1/2 and the absolute value of B. Now remember, the absolute value of A is my amplitude. If I ask you what the amplitude is, you give me the absolute value. If I ask if there's a reflection across the x-axis or anything, or if there's going to be reflection, you need to talk about it as we explore these. Now, keep in mind, again, I'm graphing this one. I'm going to graph it in green. We're looking at the idea of being able to, again, my period's 2 pi divided by b, 1. So it's 2 pi. I divide that by 4, and I find my 0, pi over 2 pi, 3 pi over 2, 2 pi. We already put it on the graph. So now I just need to make sure you realize that this is going to change. The height of my graph is going to be a vertical compression, or it's going to drop it in half. So I'm going to start here at 1/2, and then I'm going to start going down, and then I'm going to go to 1/2 and come back up. So my greens are a little lower, I'm not as high, a little closer to the axis as I go. So my A is my either a stretch, or a compression of my graph as I go through. Now keep in mind, I'm going through and it seems kind of fast. Now let's emphasize a couple things. Cosine of 0, that's my value here. Cosine of 0 is 1. But so cosine of 0 is 1 times 1/2, that's where 1/2 comes from. Cosine of pi over 2 is 0. 0 times 1/2, 0. Cosine of pi is -1 times 1/2, -1/2. Cosine of 3 pi over 2, 0. Okay, so that makes sense. It's back on the axis, and cosine of 2 pi again is 1 times 1/2. That's where I'm getting my values. So I mean, it's very similar to that each time. So as I'm going through this the period, and I have these critical points, you got to be thinking about what those values are when you're coming through. So if you get a little kind of lost, there is actually a way you can do it algebraically. I just want to make sure you recognize that this is all about graphing quickly. Now, in this last one, you'll notice that I put in these new spots. In this next one that's going to happen here, our graph is going to undergo a reflection, a flip. So I got the amplitude, here is 2, but it will flip my graph. So that's because of the negative here. So instead of high, it'll be low we'll start at, and then we'll go axis, high instead of low, and axis and low again. So when I'm starting this, and again, cosine of 0 is 1 times negative 2, I start down here at negative 2, and I go to the axis, and I go high, 2 above, because it's negative 2 times, remember, negative 1 at pi, and then back to the axis, and then down to negative 2 again. So my graph will look like this as I go through. Kind of crudely, and some of you will have much better curves than I have here. But that's what will happen when I multiply by a negative. It'll take my highs and lows in my mnemonic devices I have to help me graph, and it'll flip them. So keep that in mind as we're going. And remember, our period here is 2 pi for all 3 of these. So our 5 key points were all the same 5 key points for each graph. What we were investigating on this was the effective amplitude on our graph as we went, and what happened when that amplitude was negative. Okay, so now let's look at the B. Now B, is going to be affecting the period or length of one cycle, can change to be longer or shorter than 2 pi. If the absolute value of B is greater than 1, if this is greater than 1, the period is shorter than 2 pi. If this B value is less than 1, the period is longer than 2 pi. So B is greater than 1, it will have a horizontal compression of my graph. If B is less than 1, it'll have a horizontal stretch of my graph as I'm going. So the absolute value of B is the number of cycles in 2 pi used to find the period. So 2 pi over the absolute value of B. I kind of started out doing it, putting B underneath so you could start seeing it. And now to graph the sinusoid using the new period, P, of 2 pi over the absolute value of P, you're going to divide the new period into 4 equal parts. So once you find our period, we're still going to divide that period into 4 equal parts. We're still going to look for our 5 key points, and then we're going to use Sahala or Chala to help us graph. So here we go, and this should not be here. Let's try that again. I got that clicked apparently. So we're going to go back and talk about this, and we're going to see. So in this first one, I have 1, for my A. So that's my absolute value. My amplitude is 1. My B, my absolute value of B is 2. Now, keep in mind, as we're going through this, now I'm going to adjust my period. So now I've got my period, which is 2 pi over the absolute value of B, which is now 2 pi over 2, which is just pi long. So I will cycle, or continue my cycle, doing the same thing again, starting over after pi has gone through. So I'm going to take pi and divide by 4, and when I do that for my 5 key points, I'm going to divide by 4 and find out that I'm going to go pi over 4, pi over 2, 3 pi over 4, and pi. So 0 is going to start it all out as I go through here. So I've got to start out at 0, so that's where I get my pi over 4, my units, and then I broke up my graph, and pi over 4 is, and this is one of the harder things to do for these graphs, is be able to break it up so you have consistent numbering system throughout your period. And remember, I'm doing a sine. Sine starts at the axis, goes high, goes back to the axis, low, and then axis. So I start at 0. The sine of 0, even if it's 2 times 0, I got 0, it's 0. The sine of pi, pi over 4, or pi over 2, Okay, so 2 pi times, 2 pi over 4, which is the same as pi over 2. The sine of pi over 2 is 1. So that goes up here. And then now the sine of, times 2 times pi over 2. So that's going to be just pi. So the sine of pi is 0. Keep in mind though, because we set this up for our 5 key points, I just know my amplitude is 1. So I start at the axis, I go high to 1, I go back to the axis, I go low to -1, I go back to the axis, and I repeat. And if I just go with this mnemonic device, I can quickly graph it just based on the idea that I know that these 5 critical points, 0, pi over 4, pi over 2, 3 pi over 4, and pi, these are major points. These are going to help me figure out that on the axis, when my amplitude is 1, I can go from 0 up to 1 at pi over 4, down to the axis of pi over 2, down to -1 at 3 pi over 4, and back to the axis of pi. And that will continue throughout the entire graph, even if I'm a little bit off. And, hopefully, again, your graph drawings are better than mine. Okay, so now that's determining the period for each equation. Okay, so we got that going, and then we graph 2 full periods. But keep in mind, I still divide my period into 4 equal parts to find my 5 key points. Okay, that was divided by 4. Now we got another example here. Determine the period of each equation, then graph 2 full periods. So I got y equals cosine of 4x. So my amplitude is 1, my b is 4, and I'm going to take 2 pi divided by absolute value of b. Well, I'm going to take 2 pi divided by 4. So now the length of my period is 2 pi over 4, which is pi over 2. Okay, so now I'm going to break my graph up into pi over 2's, but be careful about this. I need 5 key points, and I'm going to start by dividing my period. I'm going to divide my period into 4 equal parts. Well, to do this with a fraction, I'm going to multiply by 1 over 4. So I'm going to multiplying by 1/4 is the same as dividing by 4. So now I have pi eighths. So I'm going to go 0 and pi over 8, 2 pi over 8, which is the same as pi over 4, 3 pi over 8, and then 4 pi over 8, which is the same as pi over 2. Okay, so I've got those numbered down. Okay, and I even went through there so you can see that I'm adding up by pi over 8. So this is pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, but I reduced the ones that I reduced. And now again, keep in mind, my amplitude still, my highest is going to be 1. I just, using more of my graph paper so you can see where everything is, because it was going to be so tight otherwise. And now keep in mind, my period, my full period is pi over 2. So I want you to realize that I start with cosine high, I go to axis, I go to low, I go back to the axis and high. And I continue repeating back because I found the 5 key points I will graph on, and this is helping me graph the cosine and sine graphs quickly. And I can do both of the sinusoids quicker because of this 5 key points that I'm graphing with, and the idea of cosines: high axis, low axis, high. Okay, now we're going to do some combinations of A and B in this next example. So we're going to determine the amplitude and period of each equation, and this will be your turn. So I want you to turn off the video and actually try to make a graph based on the information provided here, where y is equal to 3 sine 2x. Go ahead. Okay, I hope it was helpful. I hope you did some good stuff, but let's check your work. First, let's talk about amplitude. The amplitude, A is 3, and it's not going to reflect anything across the x-axis. It's just going to have a vertical stretch of 3. Then I'm going to look at my B value. My B value is going to adjust my period. So absolute value of B is 2, and my period is now pi long because I'm going to take 2 pi divided by B, and I have 2 pi divided by 2, so my period is pi. Okay, and I'm going to do a sine. So I got my 5 key points I'm going to look for. I'm going to divide by 4. So now my period is pi, and I am going to have them pi over 4 long. Okay, and so my 5 key points are 0, pi over 4, pi over 2, 3 pi over 4, and pi. So keep in mind, this is all my setup as I go. I've got this going on with my 5 key points, and I got to do this 5 key point thing to be able to use this quick graphing. So now I'm going to number my grid, okay, and then I'm going to put in my graph. So I numbered my grid, and I've got pi over 4, pi over 2, 3 pi over 4, and pi. And remember, I started at 0. Because it's sine, I start at the axis, I go up high, 1, or excuse me, 3. So it's 1, 2, 3. So it's 3, down to 0, down to negative 3, back up to 0. And I was supposed to do 2 full periods, and that's what I have. I have 2 full periods from negative pi to pi because a period is pi units long. Okay, so a period is pi units long. I divide it into 4 equal parts, pi over 4. I start at 0 to get my 5 key points. 0 is one of them. Pi over 4, pi over 2, 3 pi over 4, and pi. Hopefully you're able to get that graph done. This is the end of day 1. I hope it's going well for you. If you need to, you can rerun the video, or you can just check the notes that are online for the PDF form. I'll be back on Friday. Have yourself a great day, guys.